Okay, so I'm going to work on number 8. So generally we want to go ahead and just assume we're going to have to factor for a lot of these. All right, so the method I talked about earlier was the AC method. And the reason it's called AC is because this number is A, this is B, and this is C. So A times C for factoring. So AC means that we're going to multiply, excuse me, A times C. And when we do that, we get a negative 42. And so when we multiply the first and last, then we list the factors of that number. And the most convenient way that's going to keep things in order is to go with the smallest number. So 1 times 42, 2 times 21. I'm not even trying to think of ones that will work for the situation because I just want to list them, get them all down. And the cool thing, when you list them like this, you know you have them all because whatever comes after the previous set, like we put the 1 and 42 down, then the next set has to come from between 1 and 42, which sure enough 2 and 21 are between there. And then the set after this one comes from between here, and the next set was 3 and 14, that comes from between there. And then I tried 4 and 5 and that didn't work. 6 worked, and I know I'm done because there's no number between 6 and 7. So now we need to put our signs on these numbers. The sign of the middle term always goes on our largest row here. And they had to multiply to make negative 42. So that means these are positive since these are negative. And so now we want to look for the set that when you add them up, they equal a negative 1a. Well, this right here gives me a negative 1. And what that's going to do is it's going to allow us to write this in full-blown FOIL. See, this is F, O, I, and L, but now we can write it as F, O, and I separately with the L. So we're going to leave the first and last term as they were, but the middle two terms will be made up of a positive 6a and a negative 7a. And this allows us to do factor by grouping, where we can kind of cut the problem in half and look for what's common. So like this has a 2a, and what you have left is 7a plus 3. Well, over here, since the first term's negative, we're pulling out negative something, and there isn't anything in common other than 1. And when we pull out the negative 1, sure enough, we have 7a plus 3, just like we did. These parentheses always match. So we have 7a plus 3, and we have 2a minus 1. That comes from here and here. So the top part of this problem is factored into this set. The bottom part we're going to do the same way. Multiply the first and last, and you get 6. List the factors of 6. Middle term's negative, that's going to go on my large ones. But they had to multiply to make a positive. So that means my small ones better be negative also. So how we get the negative 7 is right here. So we're going to replace this term with a negative 1a and a negative 6a so that we can factor by grouping. So 2a squared, negative 1a, negative 6a plus 3. Cut the problem in half. By the way, I could have switched these around. I could have put negative 6 here, negative 1 here. Never matters which way you put them. Okay, so here I'm going to pull out an a. So I have 2a minus 1. Here I'm going to pull out a negative 3. If that had been a plus there, we would have put a positive 3, but it was a negative. Just kind of check yourself to make sure your signs are right by using that distributive property where you say negative 3 times 2a and negative 3 times negative 1, just to make sure it comes back up with the same thing that's there. All right, so we have 2a minus 1 inside those sets. And on the outside, we have a minus 3. So now that the top and the bottom have been factored, the top we have 7a plus 3 and 2a minus 1. And the bottom we have 2a minus 1 and a minus 3. And so now we're looking for anything that we can reduce by, eliminate the same thing. And right here we have a 2a minus 1. So now what we have left for our answer is 7a plus 3 over a minus 3.